Greetings. We will finish up our discussion of addressing modes, and we can see right here we're going to be considering first we're going to talk about what's called base offset addressing. The other name for that is called register addressing, and the corresponding load and store commands LDR and STR. Here are their opcodes. In both cases over here, there is going to be a register here, so there are 3 bits for this. Again, then there will be another register here. We'll say that's Y, Y, Y. And let's see, so we've used up 3, 6, 10 bits so far. We have 6 more to go. So then over here in either case, there is a 6-bit offset. And what's inside of here is to be interpreted as a 6-bit signed integer. So the idea, let's just consider the LDR. So if I were to say something like this, LDR, and I were to say into register R3, and I were to say R4 plus 3, okay? What does that mean? Well, it means that if I have my registers over here, and let's suppose this is R3, and let's suppose this is R4, and let us assume that R4 contains this in it, and here's what memory looks like. And here is location 4000, so this would be 3F, F, F, 4001, 4002, 4003, 4004. So let's suppose that this had hex 1, 2, 3, 4, hex 5, 6, 7, 8, hex 9, A, B, C, hex D, E, F, 0, hex 1, 3, 5, 7, hex 2, 4, 6, 8. And let's suppose that I'm going to execute this instruction. So this instruction, first of all, would look like it's an LDR, so it's a 0, 1, 1, 0, and the destination is R3, 0, 1, 1, and then it's R4, which would be 1, 0, 0, and I've got 6 bits. A 3 would be 1, 2, 3, 4, 5, 6. And the way that I think about this instruction is as follows. It is that R3 gets the memory of R4 plus the offset. So first of all, if I come over here and I get R4, R4 is 4000. And what I do is I add 3 to it, and that gets 4003. So I come over here to 4003, and I see that I've got a hex 1357, and that's going to go over here into R3. So this is going to be a 1, 3, 5, 7. Okay? Likewise, we can go the other way. We don't need this just yet. Okay, if I were to say str at, let's see, let's use R4 again. And let's, oh no, let's not say it that way. Let's make it R3, and let's say it's R4, and then I'm going to say -1. Okay, now again, what that is going to do, so the STR is going to be 0, 1, 1, 1, and I'm going to put R3 over here, 0, 1, 1. I'm going to put R4, 1, 0, 0. And let's see, I've got to put a -1 in there in 6 bits, and it seems to me, if I recall correctly, that is going to do that. Now again, let's assume that we're doing this in this picture right over here. If I'm doing it in this picture right over here, I'm going to store this number right here, and where am I going to store it? Well, I'm going to go to R4, okay, and that's got a 4,000 in it. But I'm saying subtract 1 from it. Okay, there's the whole instruction right over there. R4 minus 1 is going to be at 3FFF. So what I've in essence done is I've taken this number and I'm going to store it right over there. So what's going to happen now is this would have a 1, 3, 5, 7 in it. Okay? Pretty simple. Now, when is this used? When will you commonly see this base offset or this register addressing? And the answer is processing arrays. Okay, and let me give you an example. Suppose I come over here and here is R4, and suppose this has the number 4,000 in it. And that's R4. And let's suppose over here at memory location 4,000, I've got an array. And suppose I know it's an array of 1, 2, 3, 4, 5. And there are numbers in here. Nothing special about these numbers. Okay, but we know something that we can do something like the following. Suppose I wanted to step through these arrays. Now, first of all, if I were to do an LDR of R3, R4 plus 0, okay, what I've done is I've now loaded this into R3. So this has now come over to here, and I've got a 0, 0, 0, 3. And then I might say, let's suppose I did something like this. Suppose I did an AND R2 and R2 with 0. This is going to be an immediate AND. So here's R2. And I've zeroed it out. So now I've loaded R3. Let's see, I've loaded R3. I'm sorry, this shouldn't be plus 0. This should be plus 0, plus 0. R4 plus 0. And I've moved this into here. And now what I'm going to do is I'm going to say add R2. Let it be R2 plus R3. So what I've done here now is I have now changed this to 0003. And now here's the big trick here. I say add, I let R4 get R4 plus 1. And now R4 now has 4001 in it. Okay? And basically what I could do is I could do this loop right over here another 4 times. In other words, at this point I could say LDR R3 R4 plus 0. So now R4 has a 4001 in it, and I'm loading that into R3. So I'm going to come over here. Okay, and now what I've put in here is a 1, 0. And then I could do an add, and I'll say R2 gets R2 plus R3. So I'm going to add these two together, and the result goes into R2. So this now becomes 13. And then what I could do is I could add R4 gets R4 plus 1. So now what's happened is this has become 2. And I think you see what's going on here. So this this base offset addressing is very good for accessing arrays. And what happens when you're accessing arrays, the offset's often 0. What you're doing is you're increment the actual register that is stepping through the array. It has the addresses of the various arrays in there. So why don't we come over here and actually type this code in, and we'll watch it. Okay, so the first thing I have to do here, and I look to the back of my book, and I get an AND is a 0101. And here I'm saying R2, so that's going to be a 010. And this is going to be a 010. And it's immediate mode. Oh, it's an AND. I'm doing AND. And that is correct. And it's going to be a 1. Yes, so this is fine. And then 5 zeros. And now I'm going to come over here and I'm going to do an LDR. LDR is 0110. R3, 011. R4 is 100. And let's see, I've used up 10 bits, so I have 6 bits to specify a 0. Like that. Over here, I'm saying add, which is 0001. And I'm adding to R2. R2 is a 0, 0, 0, R3, 0, 1, 1. Over here, I'm going to do an add, and this is an add immediate. And it's going to be R4. And it's going to be R4. And it's going to be an immediate 1, 2, 3, 4, 1. I'm going to come over here, and I'm just repeating this code right over here, right over here, and right over here. I'll do it one more time. 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1, 2, 3, 4, 5, 6. I'll repeat the next line. 0, let's see, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 2, 3, 0, 1, 1, and then finally okay, so let's come over here. This is 5, this is 4, this is 1010 is A, and that's a 0. I come over here, and that is a 6. I come over here, that is a 7, 0, 0. I get a 1. I get a 1, 2, 3, 4. I get a 4. I get an 8, and I get a 3. 1, 1, 0, 0, 1 is a 9. 0, 0, 1, 0 is a 2, 1. And I think at this point, am I repeating myself? Yes. 6, 7, 0, 0, 1, 4, 8, 3, and then 6, 7, 0, 0. Is that correct? No, that is not correct. The last line is not correct. Now, we haven't completely stepped through the array with this, and we'll get a little bit fancier in the next program that we're going to write. Let's see. This is a 1, 9, 2, 1. So let's see. What do we need to do here to make this program work? We need to... R4 needs to contain 4,000 to start, and we need to put some numbers in at 4,000. So let's go ahead and do that. I get this up here. I have lots of things to move around. Excuse me. Yes, that is my keyboard that I just dropped. And let's see. I'm going to go to 3,000. And I'm going to put in a hex 5. What is wrong here? And it's going to be 54A0. And over here, it's going to be hex 6700. And over here, it's going to be hex 1483. Hex 1921. Hex 6700. Hex 1483. Hex 1921. So let's see what we've done here. We're zeroing out the register. We're loading into R. We're doing a load register R3, R4. That's good. We're doing some addition. We're adding one to the pointer to the array. Okay, so I have to come over here. R4 needs to contain that. I'm going to jump to hex 4 and start sticking some numbers in there. So I'm going to put hex 1232, hex 1234, hex 1236, and that's fine. I'm going to come back here and go to 3000. I'm going to come over here and set the PC to 3000. And I think we're ready to see what's going to happen here. So the first thing I do is I'm going to zero out R2, and that's fine. Notice it set a 0 flag. Now I'm going to load R3 with what R4 is referencing. Notice that, remember, I had entered a 2, and here it is over here. And now what I'm going to do is I'm going to add it to R2. So it's got a 2. Now what I'm going to do is I'm going to increment the memory reference. So I do that, and we are going to see that R4 went from 4,000 up to 4,001. Now what happens is I'm going to get the next number. Remember that was a 4. And see that it got added into R3. And now what I'm going to do is I'm going to add this number to R2. It's R6. And now I'm going to increment the reference again. And you can see that R4 now is pointing at 4002. So in this manner here, you can see that we are stepping through an array. Now the next question is how did we get this number 4000 into R4? And that's where we have to look at our very last type of memory addressing. Okay, our very last memory address, or memory addressing scheme. Load effective address. And sometimes some people would call this immediate, although I don't think that's quite an accurate term. And you notice that before we had load and there was a corresponding store. And we had a load register and we had a corresponding store register. And we had a load indirect and we had a corresponding store indirect. So you're wondering, is there some counterpart to the LEA? And the answer is no. So there's no corresponding store. The other interesting thing is LEA is only mode that doesn't access memory. If you can remember that, you'll have no problem with it, because LEA people find confusing at times. So LEA has an opcode of 1110, and there is a destination register here, and then there's a 9-bit offset. Okay, and again, this is to be interpreted as a signed 9-bit integer. Okay, and basically what this does right over here is the destination register gets the PC plus the signed 9-bit integer. That's it. And you're saying to yourself, well, what is that useful for? I'll give you an example. Suppose here's memory. And suppose it's 3010. Suppose there's an array that's here. And I'll just put some numbers in. So it's an array of 5. 1, 2, 3, 4, 5. Okay, and let us suppose that up here at location 3000, we're writing a program, and what we want to do is somehow we want to add these 5 numbers up. So the first thing we know is that ultimately we want to use base offset addressing over here. So maybe our base register, we decide it's going to be R4. So ultimately, what we need to do is in R4, remember what we need to do is we want to get the number 3010 in there. Because then what we might do later on is we might say something like load R3 with R4 plus 0. And then we do other stuff. And then what you do is you do this add R4 gets R4 plus 1. And this is just like the example that we did before. And we go around there like that. So the problem is just how do I get this number 3010 in there? And the answer is that's pretty simple. For example, suppose I needed to do that instruction. Suppose it's right over here at instruction 3000 where I wanted to do it. Well, first of all, when I'm at 3000, remember the PC is at 3001. Okay, and remember the offset from 3001 all the way up to here is just that far. So what this instruction could be over here is it could be a load effective address, okay, into R4, and I just specify F, okay? Load effective address is 1110, okay, and then we want to put it into R4, 100, and now we have 9 bits left over here. 1, 2, 3, 4, 1, 2, 3, 4, 5. And if this is at location 3000, this instruction over here is going to load R4 with the address 3010. Why don't we verify that? So first of all, let's convert this into hex. So that's going to be an E. And then I've got 1000 is an 8. And then I've got 0F. So I'm going to come over here. And the first thing I'm going to do, I'm going to clear all the registers. Reset all registers. And I'm going to come here at 3000. I'm going to put in E80F. So I come over here, E80F. And notice it's telling me that it's going to load effective address R4, that the PC is already set to 3000. So I want you to take a look at what happens to R4. I step, and now it's got the number 3010 in it. Okay? So that's load effective address. All right. Now, I am hoping that some of you are thinking, well, that's kind of cool, but I see some problems here. If I'm doing a load effective address, okay, this load effective address has this, what your book calls a PC offset 9. And we know that with 9 bits we can go plus or minus 512 bytes. Is that right? 1, 2, 4, 8, 16, 32, like that, and that. 1, 2, 4, 8, 16, 32, 64, 128, 256. Well, no. So it's going to be plus or minus 128. Excuse me. Getting too ambitious here. 128. Oh, it will be plus or minus 255. Okay, so in other words, if I wanted to talk about arrays, and I want to use R4, say, as my base pointer to an array, okay, if I'm going to use LEA, then what's going to happen is the array must be between plus and minus 255 bytes of the program counter. So in other words, in that last case over here, Okay, over here, we used an LEA 3000, and the array started over here at 310. Okay, and of course the PC would be at 3001, and the displacement from here down to here is F15. No problem. Okay, but what happens if I want to do the following? Suppose I want the array far away. Which is kind of a weird way to say it. Let's put it another way. Just suppose I want to put the array anywhere in memory. So suppose I come over here and what I want to do is I want the array to start at A000. So here's a number. And here's my array going over here. But yet my program starts over here at 3000. Okay? Well, what I can do is someplace over here, I don't know, at the end of my program. Maybe it's over here at 30, and I'll just say 20. What I do in here is I put the address of the array. Okay, and then what I do is instead of using an LEA up here, what do? I just use an LD. So over here I'd say LEA R4, and I would give it the offset of F. And over here I would say LD R4. And again, now remember here I'm using PC offset addressing, and here I'm going all the way up to 20, so I'm going from 1 all the way up to 32, so I have to specify 31. That would be 1F. Okay? In either case, when I'm done with this instruction over here, R4 is going to point to this array over here. When I'm done with this instruction over here, R4 is going to point to this array over here. Okay? So this gives me the flexibility of putting the array anywhere in memory. This would put the array right near the program that I'm writing. All right, finally, let's write a complicated program. At least relatively complicated. So let me get some areas to write on here. Here's what I want to do. Here we go. First of all, let's think about the following. So here's memory. And I want the program to start over here at location 3000. And what's going to happen way down here at location A000, I'm going to have an array. Actually, the array is going to start at A001. So it might have something like this. Just putting in some small numbers here. Let's see, that's 1, 2, 3, 4, 5 numbers. And what I'm going to put over here is I'm going to put how many numbers are in the array. So there are 5 numbers in this array. 1, 2, 3, 4, 5. And what I'm going to do is someplace here, I don't think this code, I have to admit I've worked it out ahead of time, 2, 4, 6, 8. It looks like there are about 10 lines of code here. So if I come over here to 320, remember from here to here, that's actually 32. I've got lots of space in here. And what I'm going to do over here at location number 32 is I'm going to put the address of this. So I'm going to put an A00 here. Okay? And basically what I would like to do is I would like to add all the entries in the array. Okay, and I don't know, where would we like, maybe we would like the, the sum is in a register. Now, the way that I proceed on something like this, I have to do a little planning ahead of time. I've got various registers here that are going to do various things. So the first thing, I'm going to say R4. I'm going to make that my pointer to the array. In other words, what I want to do is initially I would like R4 to have the number A00 in it. And I'm going to increment that, and it's going to basically step through the array for me. Okay? And somehow we know we're going to be using a lot of LDRs with stuff like that. I want R3. I'm going to let that be my accumulator. So what that means is that the sum is stored in a register. I guess in this case, the register, it's going to be R3. So a couple of things I have to remember about R3. I better clear it out at the beginning of the program. The other thing I have to remember here is remember at some point I'm going to be doing some LDR, and it's going to be R4 plus 0. It's got to come someplace. I've got to have some register here where I'm loading it into. So I'm going to let R2, I'm going to call that the receiver. Okay, and I'm going to say that's the receiver of the LDR, like that. And then basically I'm going to have R1, that's my counter. And what I want to do is I want to take this number here, this number 5, and I'm going to put it into R1, and I'm going to keep going through a loop where I'm accumulating things, and I'm going to decrement this, and as long as this thing is greater than 0, I'm going to go back and get some more. All right, so my basic idea here is, first of all, I've got to load R4 with the address. So I've got to do that. Let's see, the accumulator, R3. I've got to set that to 0. Okay, what I've got to do is I've got to get R1. Somehow or other, I need to load that I'm going to say with memory of R4. So that's my counter. So then I'm going to say, oh, actually, so then what I need to do is I need to say R4 is R4 plus 1. Let me see, I have to look at these things. So now I'm ready to get a number. R2 gets memory of R4. I accumulate. So R3 gets R3 plus R2. I have to decrement my counter. R1 gets R1 minus 1. Ooh, we're running out of space. Almost. And then basically what I have to come over here and I just have to say is R1 greater than 0? And if the answer is yes, what do I need to do? Let's see. I believe that I need to come back over to there. I increment the pointer into the array. I get the next number. I add it, subtract 1 from the counter. And down here, if the answer is no, then I'm at the end. Okay? Everybody get that? So from this, let's figure out what's going on here. So remember, this is going to be at location 3000. And at location, that's a 3000. At location 3000, remember way down here at 3020, I'm going to have A000. So we don't want to load R4 with 3020. We want to load it with the contents of this. So we know that this is going to be a load, an LD. And I need to look at my book. And that is going to be a 0010. And we're loading it with R4, so that's a 100. And remember, we're at 3001. From 3001 to 3020 is 1F. So there's a 0, and here's a 1, and here's an F. Okay, so that takes care of that. Now, at 3001, I need to set R3 to 0. Well, that's going to be with an AND, and I'm going to be using an immediate. So that is going to be 0, 1. And the destination register is register 3. And the source register is register 3. And it's an immediate. And I'm ANDing it with zeros. That just clears that puppy out right there. And now over here, I want to get so this is going to be a load register. And a load register is 0110. And the destination register is register 1. And the base register is register 4. And the offset is 0. 1, 2, 3, 4, 5, 6. And that takes care of that one. And now what I want to do with 3003 is I want R4 to get R4 plus 1. So that's going to be an add. 0, 0, 0, 1. And R4 is going to be 1, 0, 0, 1, 0, 0. I'm in immediate mode, and it's a 1, 2, 3, 4, like that. That takes care of that line right there. This is going to be at 3004. So with 3004, this looks like I'm doing a load register, which is a 0110. And I'm loading it into R2. And my base register is R4. And there is no offset at all. So that's that instruction there. Over here I'm doing an add. That's at 3005. Let's just get rid of this for a moment. So with 3005, I am doing R3 is equal to R3 plus R2, so I'm going to be doing an add. R3, R3, R2. like that. Over here, 3006, R1 is R1 minus 1. So I'm going to be adding a minus 1, 0, 0, 1, 0, 0, 1. That's a 0, 0, 0, 1. And this is immediate mode. And I've done this enough times to know that 1, 2, 3, 4, 5 is minus 1. Okay. And 3006, 3007. So what I want to do here is a branch, 1, 2, 3, 4, and I want to branch if the result of this was positive. So it is negative 0, positive, and here's the tricky part. Where do I want to go back to? Well, according to this, I want to go back to this R4 is R4 plus 1. That's 3003. So I want to go back to 3003. But where am I now? Well, first of all, remember, if I'm at 3007, the PC's at 3008. So that's 3008, which means I need to come up with a minus 5. Okay, well, let's do the calculations, and let's see, for the branch instructions, it's 9 bits. So 5 is 1, 0, 1, 4, 5, 6, 7, 8, 9. I want it to be minus, so it's 1. And I add a 1 to it. And it's that. So over here, I get 1, 2, 3, 4, 5, 6 ones. 1, 2, 3, 4, 5, 6. And then a 0, 1, 1. And that looks like my program. Let's see how it works. So first of all, let's do some translation here. That's a 2. That is an 8. That is a 1. That is an F. Over here is 1, 2, 4, 5. Here is a 6. This looks like an E, 0. This looks like a 6. 1, 2, 3, 4, 3, 0, 0. This looks like a 1, 9, 2, 1. This looks like a 6. This looks like a 5, 0, 0. This is a 1. This is a 6. This is, let's see, 8 plus 4 is 12. That's ABC. 2. Here is a 1. Here is a 2. Here is a 0. 1, 1, 1 is a 7. F. And here is a 0. 3. F. Let's see, that's 8, 9, 10, 11 is a B. Okay, so remember at 3020, we have to put in A, 0, 0, 0, and then at A, 0, 0, 0, we have to put in a 5, and then the rest of the array. Let's try it all out. So I am going to come over here. Excuse me while I move things around. X 281F. X 56E0. X 6300. X 1921. X 6500. X 16C2. X127F, X03FB. And let's just take a look at this. I think that's what I want it to be. Let's come over here to 3020. So at 3020, I'm going to put in hex A000. Let's go to A000. And here, I'll say that there are 5 elements in the array. And I'll just type in the first 5 odd numbers. And what I'll do just as a check here, I'll put in something like, I don't know, like that. So what'll happen is if my sum comes out to be very large, I know my counter was off and I did too much. So I'm going to come back here to 3000. I'm going to come over here, I'm going to reset all registers. This is set at 3000. Everything looks okay, so I think we're ready to go. So I'm going to step. Okay, and the first thing I note is that R4 now contains a, like that. I'm going to zero out R3. That's good. I'm going to load R1 with R4 plus 0. Notice now that R1 contains our counter. That's kind of cool. I'm going to add one to R4. We're at A001. I'm going to load R2. So let's see. I loaded R2. Notice we read in our first number, which is 1. Now I'm going to add it to R3. So R3 is 1. I'm going to subtract 1 from our counter. So 5 went down to 4, and I should go ahead and I should take the branch. So it went back there, and I am going to add 1 to R4. So R4 now went up to A002. Now I'm going to load R2. I'm getting the next number. Notice the next number, R2, now has a 3 in it. Okay, I'm going to add R2 to R3. So notice R3 now has 4, which is 1 plus 3. I'm going to subtract 1 from R1. Just went down to 3. And I take the branch. I add 1 to R4. Now it's at A003. I'm going to load R2, so I should be getting my next odd number. Notice that it just went from 3 to 5. I'm going to add that to R3, so that should go from 4 to 9. Look at that. I'm going to subtract 1 from R1. It's now down to 2. I take the branch. I add 1 to R4. I'm at A004. I'm going to load R2. I just got a 7, which is great. I'm going to add that to R3. Okay, so 7 plus 9 is 16, so R3 should become 1, 0. Oh my goodness, isn't this wonderful? I subtract 1 from R1. It's now 1. I branch back up to the top. I add 1 to R4. Okay, I load R2. So that got a 9. I'm going to add 9 to 16. That should give me a hex 19. Look at that. I am going to subtract 1 from R1. Watch what's going to happen to the flags now, because notice right now the flags are positive. It's going to go to 0. It's set it to Z. And now I am not going to take the branch. So when I hit the step, it's actually going to come down to here. And it did. So by the way, I come back here and I look at R3 and I see 1, 9. That's 16 plus 9 is 25. And if I go 1 plus 3 is 4 plus 5 is 9. Plus 7 is 16. Plus 9 is 25. Boy, it worked. Kind of cool, isn't it?